Okay, what we're doing here is we're doing composition of functions. When you see this, okay, here's what it's telling you to do. First of all, you're going to plug something into the outer function h of x. And h of x is the square root of something, right? What are you going to plug into it? What is in parentheses? It is g of 12. So let's go off to the side. What is g of 12? It's like there's two parts to this. G of 12 means go get the g function, which is x minus 3, and plug in. Remember that when they put a number in here, they're telling you what to plug in for x. You're plugging in x is 12. So what is 12 minus 3? It is 9. So what this tells me is that g of 12 is 9. So we could have written this same problem as h of 9. Since g of 12 is 9, this is the same thing as saying find h of 9. So it's like you look at the outside one, which is the square root of x, square root of something, and what you're going to plug in is what the inside part, g of 12, equals. So you've got to go figure it out. So we're actually finding h of 9. So if you look at h of x, it's the square root of x. Well, we're finding the square root of 9, which is 3. That's all you're doing there. It's just, you just kind of have to learn how to read these. Sometimes they write this same thing as, I'm not going to tell you that yet. Let's wait on that. Let's look at B on 5. B says h of g of 2. Okay, so if you think about the outside part, h, you're going to look at that as the square root of something, okay? Square root of whatever we're going to plug in there. Well, what are we going to plug in? G of 2. So let's go off to the side and find g of 2. What is the g function? Oh, it is x minus 3. And they're telling me to plug in 2 for x. So 2 minus 3 is negative 1. So g of 2 is the same thing as negative 1. So what am I going to plug into this h function? It's the same thing as saying h of negative 1. So I'm going to put a negative 1 in there. Now, what is the square root of negative 1? Well, we know that's the imaginary number I. They asked for real number values, so we're not going to give that because that's not a real number value. We're just going to say no real solutions or not real or something. I think the book says not real. I'm just going to put no real solutions because they ask you for real solutions. They didn't ask you to give an imaginary solution. Let's look at C. C is h of g of x. Okay, so this one looks a little bit different in that there's not a number plugged in here that we can go find. So if you remember, let me write h of x and g of x out here. H of x was the square root of x, and then g of x was x minus 3. So you start here, you go, okay, what is h of x? H of x is the square root of something, square root of x, whatever x is. Well, what are we going to plug in for x? We're going to plug in the whole function g of x. Well, g of x is x minus 3, and they didn't give me a number to plug in there, did they? So since they didn't give me a number, I'm going to take this whole x minus 3 and stick it in under here. And I would get my answer, the square root of x minus 3. All right, number 7, and you're doing the odds there, so you're going to be doing 7 and 9, and they say use the horizontal line test to tell whether the function has an inverse. If so, draw the inverse by reflecting it across the line y equal x. Okay, I'm going to do the ones that you were assigned both have an answer of no, so I'm going to do one of those, and I'm also going to do one that actually has an answer of yes, since we need to see one that says yes. Okay. The vertical line test would say this is a function in itself. But if we do the horizontal line test, instead of drawing vertical lines, we're going to draw horizontal lines. And if you draw a horizontal line and you hit more than one point, the inverse will not be a function, okay? So this is not, the answer here, is there going to be an inverse? No. What I actually do with this, if I want to find the inverse, is I just restrict it. I say, well, since the whole thing's not a function, I'll just look at half of it. So what we would do is graph half of it like this. Now how I know what to do is there's a point 0, 0 there, for instance. So that would be if I flip, remember when you graph an inverse, you flip the x and the y coordinate. Your x is 0 and your y coordinate is 0. If I come over here and I flip them, it's still 0, 0 on the inverse. Let's find another point on this graph. If you look in the book, you actually have the point 2, 3. So let's just pretend this was the point 2, 3. I didn't draw coordinate scales in. So on the inverse, if I graph that, I just switch the coordinate points. The x becomes the y and the y becomes the x. You just basically flip it. I'm going to graph the point 3, 2. So 1, 2, 3, 1, 2. Let's say it was there. This is how I can graph the inverse of a function, simply by switching coordinate points. And if you were to look at this, if you were to put both of these on your calculator, if you had the equations, what happens is, I'm going to draw this in purple. If I were to do it on the same coordinate graph, they would be reflected across the x-axis, okay? So I actually didn't do a good job of drawing that one. It's another way you can do it. So let me try another one that way. Let's look at number 8. And honestly, I have a hard time reflecting about the line y equal x. This is the line y equal x. And if you, I think I said x-axis a minute ago, but you actually reflected a line across the line y equal x. That's what an inverse looks like, and that's how you can tell you got an inverse. If you look at the two graphs on the same coordinate graph and they're reflected around this line y equal x. And this line y equal x, it basically cuts quadrant 1 and quadrant 3 in half into 45-degree angles. If you remember from geometry, that might be useful. Okay, if you look at number 8, for instance, it's kind of hard to do this when you don't really have a good coordinate graph to work on, but I'll try my best just to try to explain this to you. All right, so if you look at this, you've got some points. I'm going to turn the recorder off and graph. Okay, here's the original function on A. I just graphed it in red like it is in the book. And if you do the horizontal line test, if you were to draw a horizontal line, I'm just going to use yellow, it's only going to hit one point anywhere you draw it. So this one does have an inverse. Now, there's two ways you can graph the inverse. I'm not very successful at graphing the way they tell you to do it. I'm going to first draw in the line y equal x, because when you graph an inverse, it's just the regular function reflected around the line y equal x. And the line y equal x contains 0, 0, 1, 1, 2, 2, and actually I did not draw that right, because this red point here, let me fix it. This red point here that I drew here, it should actually be here 1, 2. So this isn't correct here. Okay, I'm going to kind of scribble it out. So I'm in green, I'm graphing the line y equal x, 2, 2, 3, 3, and then -1, -1, -2, -2, -3, -3. Okay, so this is the line y equal x. And what you do is you count the same distance. You try to go perpendicular to the line on one side and then go perpendicular off at the other side and count the same distance over. Now what I find easier to do is to take those good points that we have, and I'm going to list those points in red since I graphed in red. There was the point 1, 2, 0, 1, and -1, 0. And if I want to graph the inverse, I'm going to graph this in blue. If I'm going to graph the inverse, all I got to do is flip those points. So my inverse will be the points graph 2, 1, 1, 0, and 0, -1. Because you're taking a point, and what you're trying to do is get the point back when you do whatever the inverse function is. You're trying to start with the x, and then you're trying to get the x back. Okay? So what you do is you actually flip the points to graph it, and that's the way most people do it. So I'm going to do it that way because it's just so much easier. So if I graph this inverse, it's going to be 2, 1, 1, 0, and 0, -1. And I know that it's supposed to, let's see, let me try another one too. Let me just kind of pick something else just because I'm having trouble getting the shape, that shape. It's actually going to do something like this. If you look above that, the graph's getting further away from the green line. The red graph's getting further away from the green line, so it'll be something like this. It'll be like, and then it would cross over here and do something like this. So you try to pick your good points, and maybe some more points would have been good here. But you're basically trying to get the same distance away from the green line with your blue graph as you are as your red graph, with the inverse graph as the original graph. And again, it's easier just to flip the points and graph them and then try to eyeball the rest. just would have had an answer of yes. It's the only one of the three that would actually have had an inverse on that section.